All right, so we are talking about whether or not you should believe a statistical study. There are actually 8 guidelines that are um, used for critically evaluating a statistical study. The first one is to get a big picture view of the study. So understand the goal, the population, what was the study, or was the study observational or experiment? Look for the second one is considering the source. Look for any potential biases on the part of the researchers. So look for bias in the sample. Decide if the sampling method was likely to produce a representative sample. Sometimes there's selection bias. Researchers select their sample in a biased way. So you need various groups. There's also participation bias. So that's participation in a study is voluntary. This is the most common form of participation bias. We'll get into some of the examples, but basically a restaurant review. Researcher bias. Researcher has an opinion that affects an outcome. And then looking for problems, defining or measuring the variables of interest. That's number 4. It's hard to define some variables. This can make it difficult to interpret the reported results. Number 5 is beware of confounding variables. If the study didn't know about a variable, its result may not be valid. Number 6 is consider setting and wording in surveys. Does anything produce inaccurate or dishonest responses? Number 7 is check that results are presented fairly. Does the study support the conclusions that are presented? And then number 8, we have to stand back and consider the conclusions. Did the study achieve its goals? If so, did the conclusions make sense and have practical significance? Peer review is one of the processes to prevent some of the issues. It's where several experts in a field evaluate a research report before the report is published. Peer review is one way to help verify a study's validity. If you've taken your English 1301 and 1302 class, you might be doing a peer review in there where you have somebody else in the class review your paper, make sure your margins are right, make sure your paper's on track and making sense, that kind of thing. So we're going to look at some different examples, and any of these that we haven't covered, I'll come back and cover in further detail. All right, so we are going to imagine the following hypothetical newspaper report. Researchers gave 100 participants their individual astrological horoscopes and asked whether the horoscopes were accurate. 88.5% of the participants said their horoscopes were accurate. The researchers concluded that horoscopes were accurate. The researchers concluded that horoscopes are valid most of the time. We need to analyze the study according to Guideline 1. So Guideline 1 is get a big picture view, the goal and the population. All right, so what was the goal of the study for that first example there? What is our goal? Normally I would be asking you in the classroom, but I can't hear you because you're not there. So this will be example 1, and this is 1.4. I like to put the section so I know what lesson plan it was. So for this one, our goal of the study determined is to determine the validity of horoscopes. All right. Now, based on the newspaper report, it appears that the study was what kind? So the researchers gave it to 100 individuals and asked whether the horoscopes were accurate. So they didn't really do any kind of experiment, but it was observational. They observed the participants. They just asked them, about their accuracy of their horoscopes. Now, because accuracy is a subjective thing, right? So accuracy is subjective, which means it's like an opinion, right? It's kind of like we did another one where they were assessing politeness. It's an objective or subjective thing where their results from the participants was kind of like an opinion. So what could we have done to fix that? Well, we should have had a controlled experiment, and with that we would have had a treatment and a control type group, even though we're not doing an experiment. But you guys still kind of think along those lines, where you have to have some kind of, because you're asking, is this accurate? So maybe we have some fake horoscopes. If we gave some fake horoscopes, then maybe, so this would be kind of like the placebo, right? Maybe then you'll see, hey, did they think the fake horoscope was just as accurate? Because a lot of times when you look at those, they could be, you can apply it to how you see the horoscope. Like, how do you see that it actually is applying in your world? Oh, yeah, I see that because of blah, 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 or blah, blah, blah. So that's where it's kind of subjective. And if we had done the other group, then the researchers could have looked for differences between the two groups. Also, we could have had a little bit of experimenter, right? So depending on how they question the participants, so maybe in this case here, we had an experimenter effect, right? Depending on the tone and body language, on how it was asked. Were they excited to see what they had to say? Like, oh, did it apply? Do you think it was accurate? Versus like, So what should this have been? This should have been a double blind, right? We needed a double blind. So that way we would not have to worry about that. So the type of study, basically this type of study was inappropriate because it's not going to tell us anything. And because of that, the results are meaningless, right? So this type of study was inappropriate for what they were trying to find. Not like it was an inappropriate behavior, but for results, they did an inappropriate study. They should have done a double blind with some fake horoscopes in order to really know. So this tells us that the results are meaningless. So they didn't do any good to even do this one. Okay? All right, let's go look at example 2. By 1963, research had so clearly shown the health dangers of smoking that the Surgeon General of the United States publicly announced smoking is bad for health. Research done since that time built further support for the claim. However, while the vast majority of studies showed that smoking is unhealthy, a few past studies found no dangers from smoking and perhaps even health benefits. These studies generally were carried out by the Tobacco Research Institute, funded by the tobacco companies. Another Analyze these studies according to Guideline 2. Consider the source. All right, so let's talk about this one. So in a case like this, it can be difficult to decide whom to believe. However, the studies showing smoking to be unhealthy came primarily from those peer-reviewed papers. We talked about peer review a minute ago. These papers were peer-reviewed. In contrast to that, you have the studies that were carried out by the Tobacco Research Institute. And they had a clear potential for bias, right? They want the study to say, hey, smoking's great for you because they're making money. So the potential for bias does not mean the research was biased, but the fact that it contradicts virtually all other research on the subject should be cause for concern. So let's make a couple of notes here. So, for the studies that show unhealthy, they were peer-reviewed, which means they were more likely to be believed. And the studies that show healthy were by the Tobacco Research Institute. Well, they don't want tobacco to be bad because then that means people aren't going to smoke, right? So this had a potential for bias. But like we said, just because it had the potential doesn't mean it necessarily makes the research that way. But this one completely contradicted the other one. Like they were on two opposite sides. So that's going to cause you some concern. Now the interesting part here is that in 1999, the Philip Morris Company, they were the largest, world's largest seller of tobacco products. Philip Morris was a very well-known name in like the 70s and 80s, 90s. They have publicly acknowledged that smoking causes lung cancer, heart disease, and emphysema, and other serious diseases. And then a short time after that, they actually changed their name to Altria. So they took away their Philip Morris Company name because it was mud, because they had lied to the public. And they changed it to something else that people might not realize it was the same company. Because I'm sure that wasn't like super headline news. All right. So got to watch out for that bias part because of who's doing the research. All right, example 3. Radon is a radioactive gas produced by natural processes. It's the decay of uranium that happens in the ground. The gas can leach into buildings through the foundation and can accumulate to relatively high concentrations if doors and windows are closed. Imagine a hypothetical study that seeks to determine whether radon gas causes lung cancer by comparing the lung cancer rate in Colorado, where radon gas is fairly common, with the lung cancer rate in Hong Kong, where radon gas is less common. All right, so we have, so suppose the study finds that the lung cancer rates are nearly the same. Would it be reasonable to conclude that radon is not a significant cause of lung cancer? All right, so the lung cancer rates are nearly the same, but we're comparing Colorado in the United States to Hong Kong over in the Orient over there. And so there's a lot of, there's some differences in the ground and in the population. So what do we see here? So let's look at the variables of interest. Maybe that'll give us some first clues. So example 3, if we look at the variables of interest, they're going to be the amount of radon, the amount of radon, and this will be the explanatory because it might explain why you have lung cancer, okay? The other one's going to be the lung cancer rate. And this one's going to be the response. It'll be the response variable because the lung cancer rate is going to respond to the explanatory rate. However, radon gas is not the only possible cause of cancer, right? What is another one that we know is a possible cause of cancer? We just talked about it, and that is smoking. So, you've also got a confounding variable. So we have smoking that can cause cancer, right? And specifically, we're looking at lung cancer, right? This is going to be our confounding variable. Okay, because that's a whole nother part, because you're not looking at just people who are with the radon and there's no smoking, right? So, because we're looking at that radon's not the only possible cause of lung cancer, and this is just one of the possibilities. So, for example, with that, because the smoking rate in Hong Kong is higher than the smoking rate in Colorado. As a result, we can't draw any conclusions about radon and lung cancer without taking the smoking rate into account. And there could be some other variables that are happening there as well. I mean, you've also got all kinds of things because it's a whole different culture, right? So there can be a lot of different things. So careful studies have actually shown that radon gas can cause lung cancer, and the United States Environmental Protection Agency, also known as the EPA, recommends taking steps to prevent radon from building up indoors. So radon gas does cause cancer, and specifically lung cancer, but to compare it with Hong Kong, it's not quite the same because of all the other things. And you've got so many other confounding variables. So they're going to have to look more closely and do a better study. And that one was, we did not put which significant one. All right. So that one would be number 5 as well. Beware of confounding variables. We're also getting a bigger picture on that one, right? Of what's going on. On the previous one, we could have also looked at considering the source because of the tobacco industry that was producing the survey. All right, so let's go look at number 4. So we've got the Republican National Committee commissioned a poll to find out whether Americans supported their proposed tax cuts. Asked, do you favor a tax cut? A large majority of respondents answered yes. Should we conclude that Americans supported the proposal? So there's some more things that are happening in here, right? So, do you favor a tax cut? Well, let's talk about how that's being presented, right? You don't have another option. You don't have a bigger picture of what's going on in this study. Because if they just say, hey, do you want a tax cut? Well, of course we do, because we want more money in our own pocket, right? But the way it's being asked is a little bit biased because they're trying to lean you towards one side. Because the only answer, I mean, you have a choice of yes or no, but without any further explanation, you're going to choose, yes, I want a tax cut. But in fact, there were some other polls conducted at the same time that showed a similarly large majority expressing great concern about federal deficits because they're spending more money than they're bringing in. So if we cut the taxes, we don't bring in as much money, therefore the deficit's going bigger. And indeed, support for the tax cuts were far lower when the question was asked by independent organizations in the form, would you favor a tax cut even if it increased the federal deficit? Well, they don't want that federal deficit because then that causes all kinds of bigger picture things of our debt ratio with the country as a whole. So in that case, they're going to be like, well, no, I don't want to do that because, it's more about, cutting spending, but got to live within your means. All right, so for example 4, we're looking at biased. And biased would be guideline number 3. And it's because there's no other options. No other options are given, and no consequences are discussed. So the question is being presented biasedly because they want you to say yes. All right, example 5. The school board in Boulder, Colorado created a hubbub when it announced that 28% of Boulder school children were reading below grade level, and hence concluded that methods of teaching reading needed to be changed. The announcement was based on reading tests on which 28% of Boulder school children scored below the national average for their grade. Do these data support the board's conclusion? All right, so 28% scored below, but what does that mean? There's a total of 100%, right? If 28% scored below, how many scored above? Well, if I take 100% minus 28%, we get 72% scored above. Scored above that national average, right? So 72% above sure sounds a lot better than 28% below. So the school board's ominous statement about students reading below grade level makes sense only if grade level means the national average score for a particular grade. Now, that interpretation of grade level is curious because it would also imply that half the students in the nation are always below grade level, right? So if this is grade level, we have above and we have below, 50% are going to be above and 50% are below grade level. That's typical what we're going to see. That would be the expected value. Half are above and half are below. So the fact that they were only 28%, but there's 50% out here, that's going to be a whole nother thing like so. And it wouldn't matter how high the score is because you're still going to be, basically in a half and half situation. So it may still be the case that teaching methods needed to be improved, but the data that they presented did not justify that conclusion. So that's going to be, like looking at what are some of the things of the way they're defining or setting that up. So this one would be like a stand back and look at the conclusion. They didn't justify the conclusion, right? So that would be like number 8. The conclusion was, hey, they got to teach it differently. Well, not by this data. On the previous one, where there was bias and no other options given, no consequences are discussed, that could have also looked at looking at the setting and the wording in the survey because they didn't give you more as well besides the bias. And this one, where we're looking at the score, maybe the results aren't presented fairly because they're focusing on the 28% below instead of 72% above. So some of these, it's not always the easiest to decide which guideline. Just realize that some of that's gonna kind of fall in there. Typically in the homework, I think they kind of give you a better clue on it, or they're a little more straightforward. All right, does it make sense? If you use a large enough sample, it does not matter if the sample is biased, so the treatment must have practical significance. So read that again. Does it make sense? If you use a large enough sample, it doesn't matter if the sample is biased, so the treatment must have practical significance. Well, you know what? If it's biased, it doesn't matter how large it is, right? If it's biased, it's not going to have practical significance, and there's an issue with the way that it's being conducted. So for example 6, it does not make sense. So it doesn't matter how it is going to be is biased, no matter how large the sample is. If it's biased, it's biased. Okay? All right. So you've got another activity here. The activities are not there to punish you in any way. It's to help you actually understand the concepts a little bit better. So you've got guidelines are listed there, and you're going to choose which guideline. On this, I try to make it very clear that there is which one you would choose, but you're also going to explain your reasoning. And therefore, like if your reasoning makes sense, even if you didn't pick the guideline that I might have picked, if it makes sense why you chose that, you can still get credit. Just to be clear, everything is partial credit in this course. In case you weren't sure of that, there's partial credit for all the things that you do, and including the exams. So make sure you're doing everything that's assigned to your homework for 1.4, and then make sure you get your activity taken care of as well.